Hello everyone. Today I'll be talking to you about silk. So what is silk? Silk is a natural protein fiber produced by silkworms and spiders. Spider silk generally has much better mechanical properties than silkworm silk, although they do act very similar. However, spider silk can endure greater extremes such as temperature extremes, and it does have an impact on the mechanical properties, which is why spider silk is generally better. And I'll be predominantly focusing on the spider silk properties over the silkworm properties, but keep in mind that they do act very similar. So, we'll first talk about the elasticity of spider silk. So, it is incredibly elastic and it can stretch many times its original length. And what's very interesting about it is that when it's stretched, it doesn't lose any of its mechanical properties. In fact, it only gets stronger. Um, However, one of the problems in the practical uses of it is that once it is stretched, it's hard to get it to go back to its original form, and generally it only actually goes back when it gets wet, but we'll talk about that a little bit later and what happens when it does get wet. So next I'm going to talk about the strength and toughness. Now, strength and toughness sound like they should be the same, but they aren't. And I believe we've talked about this a little bit in class, but just to go over it briefly, strength is the force that a fiber can support, and toughness is its energy absorption. And so spider silk is much stronger than steel, but it has just 1/6 the density, which is incredible for something like a natural fiber. And spider silk and Kevlar are very similar in strength, yet the elasticity and energy required to break down, aka its toughness, are much higher. As you can see in the chart below, dragline silk, which is just another term for spider silk, its strength is very similar to Kevlar's, even though Kevlar is a little bit stronger. You can see that silk can stretch many times more than Kevlar, and its energy, or its toughness, is significantly higher than Kevlar's. Here again, you can see the strength and toughness on a graph. So the strain at the bottom is how much is being stretched. And you can see, obviously, Kevlar can't stretch that much, but spider silk can. And the more you stretch it, you can see the more tensile strength it has. And in fact, it gets very close to what Kevlar can get to under normal conditions. So now we're going to talk a little bit about the temperature properties that I touched on before. So typically, spider silk can retain its strength within the temperature range below -40 Celsius to 220 Celsius. But at these extreme temperatures, the properties quickly degrade. And like I said, silkworm is similar, but it gets damaged much more to sunlight exposure and extremes. Um, but because of these properties, silk is a great clothing accessory to wear in either the winter or the summer because it's able to breathe nicely in the summer and it retains warmth in the winter. And so now we're going to talk about what happens when silk gets wet. Like I touched on before, when it's wet, it contracts. And before I said silk doesn't usually contract, however, when it's wet, it does contract. But the problem is when it's wet, it loses a significant proportion of its properties, I think about 20%. And what it happens to silk, like normal silk that you and I are used to in our everyday lives, is it gets very transparent and it can shred and rip very easily. And then we can touch on the density one more time. The silkworm silk is about 1 denier and spider silk is about 0.15 denier. So before, when I was mentioning how spider silk was stronger than steel, yet a fraction of the density, you can see now, in terms that we've already discussed in class, what that actually represents. Um, so, spider silk is quite an amazing natural fiber, and the only reason we don't really use it as much as we should in everyday lives is because it's incredibly difficult to harvest from spiders, and man-made spider silk is just incredibly expensive at the moment. There's a lot of research going on about how to improve the processes to make synthetic silk, and when we find ways to make it cheaply and efficiently, I'm sure we'll have a lot of cool new silk products to use. Thank you for your time.